Hello everybody, to all people who is listening me, who watching my presentations. I'm really appreciate it. Thank you for joining my channel. Today we will start from a bit puzzled presentation about hardware encoder decoder. I still continue with GPU decoding. Then it's just add on a bit more than I've done for the last couple of years. Today then it will be some how to set or how to use or how to actually plan for the new hardware encoder, decoder or transcoder. Is depend your usable scenario you want to use. As well, today is bit more on the Yocto projects, and for example I'm going to example it with UP2 board, but it can be with any board you're going to choose. Then let's start from the overview of what I'm going to talk about, and you will see what I'm going to present today. Then we will start from some hardware selection, what reasons and what the scenarios you need to choose to select the proper hardware. As well, how after you've chosen hardware, how you can customize the Yocto and what is Yocto at all. As well, how to configure GPU on selected platform, how to simulate the GPU decoding and encoding or transcoding on the selected platform, and some useful tools. It's all depend on the platform, of course, but the tool I've chosen to show you how you can actually check the GPU. You've probably seen it in my previous presentations a few times ago, and this will be additional tools that you can use. So the board selection is a bit puzzled because it's the memory, Ethernet, CPU and GPU. It's sometimes different USB ports or display ports. Then the selection of board is depend on your scenario, what you want to create. You want to create the decoder board, for example, or you want to create an encoder board, or you want to mix and match. Use some of the board for the decoding, some of the board for encoding. As well as depend on the codec you're going to choose, like H.264, H.265, VP8 or VP9, or if you want very oldish one, VC1 for example. Then those factors depend on how you're actually going to choose a board. You can make yourself board, which is take quite a long process, but you can choose somebody else board and then utilize it for your scenario. Today in presentation I'm going to present some UP2 board. It's absolute as an example. You can choose any other board, and I'm going to choose Apollo Lake CPU. Then from looking on the UP2 board is quite everything already in place. eMMC, CPU, couple of USB ports, HDMI and display port, couple of Ethernet ports, and it's quite a lot of hardware that you can utilize. And platform selected underneath is Apollo Lake. It's not the latest fashioned platform, but at least it does give me some sort of ability to use GPU, to use CPU properly. It's a couple of CPUs and it's 18 GPU units inside, and it's quite good chunk of memory, and it's fast memories as well. Therefore, if you chosen this board or you chosen other board, with no matter what platform it is inside, you need to, of course, investigate a bit further, like if your platform give ability for some certain codec to do what you want to achieve. So if you're going deeper to Apollo Lake, how to actually look inside and understand, for example, for the VAAPI drivers, the media drivers that used for Intel Apollo Lake, for example, this is a board, Apollo Lake, Broxton. We can actually already see the H.264, it will support encoder and decoder and couple other codecs, and maybe interested in HEVC 8-bit, which is thus a bit limited because it does have decoders, full features and free kernels, but encoders is only ES and it doesn't support free kernels for encoders, for example. It only supports full features. But this is other Intel boards like Cobalt Lake, Skylake, and you can probably this is a cut down version of the table, but you might choose to read all the table and choose a much proper platform for you. But what we do interest as well is what the resolution it's and what the format it will be supported. For example, we can decode on the Apollo Lake up to 4K stream, which is quite decent quality because it's still not 8K, but it does 4K. For example, MPEG 2 it's only 2K, but for the H.264 it's 4K. And the format is used is NV12. Make sure you understand what's the difference between NV12 format to YV, for example, and its different color conversion formats. And for H.265 it does have 4K support resolution, which is quite good quality as well. So it is about codec support and about GUK, DMC and HUC. You need to know that how actually when the kernel is loaded and kernel is running and you run the application, how actually it is data transferred from the CPU to GPU using graphic workload scheduling and various graphic parallel engines, how they actually transferred between board to GPU unit and back. To make it a bit simpler, you can choose Yocto project, for example, because you can use the kernel like Ubuntu, standard Ubuntu, but if you choose standard Ubuntu, for example, or Windows operating system, it comes with a lot of modules and a lot of tools that you might not need on the board, and the space occupied and the memory occupied and all infrastructure that would use all the tools that going with standard operating system is too large. To minimize it, you can choose Yocto projects that it comes with different recipes for different platforms, like for Android, for example, for different chips, different MIPS, and you can mix and match if you're going forward with Yocto project and build yourself very limited image that can be run on most of the platforms, and it will have only the tools you need to use, and it will be light, fast, and it will do what you want. So for the Intel BSP, for example, if you follow this link, is a step-by-step user guide how actually you can build the Yocto project on the Apollo Lake Leaf Hill ES39000. And this is from the left side. It's a bit of diagram how the Yocto folder structure look like. It isn't intuitively easy. That's why I'm saying it's a bit puzzled. But replacing some of the recipes it's available, like if you today use GStreamer version 10.16.0 and tomorrow the GStreamer is updated, you just replace the recipes and build your Yocto again and you get the new GStreamer. You don't need to wait for the GStreamer released format to try it. The same with any other recipes for the graphics, for the Ethernet, for whatever you want. Then this is placed, for example, for Intel middleware, and you can find tons of recipes on the internet to use. So to build Yocto, it might be not intuitive for the first time user. For the advanced user is already people know what to do and where to go, but for the first time user you can just go build your Yocto project Probably it wouldn't work from the first go, but hopefully it will build from the step-by-step operation. After all is built, you just start to replace the, you can replace the recipes and rebuild again. For the advanced user, you know what you want to replace, you take the Yocto project, you download all the tools, and then you replace the tools. For example, you can change the media SDK, GStreamer plugin, and all of these plugins that you want to use for the streaming, and then you build the image. Then it depends how long you spent on Yocto project previously, but from the first time user it will be just longer process, but it will work as well. This is a bit of instruction how you can build special project, for example. You don't need to follow full instruction and wait a few days. You can just stop at some point and create minimal image or create SATA image. And if you want to replace some of the recipes, or recipes is failing because of build, you always can use clean all and recipe name, or you can rebuild only special recipes and recipes that dependent on the recipe you want to rebuild. For example, this is an example of GStreamer replacement. It's replace full GStreamer packages and will rebuild them and download them again. Now, it is, as I mentioned, there's a ton of different recipes. People made already recipes for different tools, then I can't really specify all hundreds of different tools and you would like to use or would need to use on your project. Then if you just specify GStreamer, then GStreamer, but if you need something else, maybe it depends as well from the platform. If I've showing here is Apollo Lake is Intel platform, then I depended on VAAPI driver, on media Intel driver. But if you choose something else, you will need driver specific to your platform. Like if you choose some GPU from NVIDIA, you will need different drivers for this. So GStreamer, it's very interesting project that, if you remember my previous presentation, maybe not, but it doesn't matter. I've presented quite a lot of FFmpeg, and all my encoding, decoding, transcoding was based on FFmpeg project. Now it's probably worth to mention, because GStreamer it's quite usable set of libraries that can use underneath FFmpeg as well. Then it's bit of high level of hierarchy, and it's quite usability of GStreamer is much larger than FFmpeg. Especially it can use FFmpeg inside, and it's quite useful to make some streaming. And it's easy to make some streaming, easy to make player, easy to make transcoder, decoder, encoder, especially if you want to use GPU. And you will notice now how easy it is. For example, because we chose an Apollo Lake is Intel Media VAAPI driver, we can use GStreamer, for example, in the occasion. Go through the GST is GStreamer plugin, through GST VAAPI, get down to the libva driver, UMD driver, libdrm, is through directly contact the VAAPI driver. And we have option to get through GST MSDK, which is Microsoft MSDK library, which is most of from the libva, it will use the same API, but it will go through the different route. So, and as well, I can draw here another line with FFmpeg route, and FFmpeg will go through the libva as well. Then it's very usable to use different plugins and mix and match what you want to use in your application. Then if you want to replace some or reuse some packages or rebuild some packages with later versions, you can update the recipes in your Yoctos and drivers. You can always replace this, replace drivers, replace libva, replace MSDK, and then rebuild Yocto, you will receive the maybe bug fixes that is failing with your current version. Now, it's very easy. It's very simple example. It's tons of example how you can use GStreamer. Then this is one of the example. For example, generate the sample stream from your VM machine and send it to the UDP multicast link. Which what we can see here is GST launch, some test pattern. It will use as an input 1080p stream, 30 frames per second. The test stream actually you will use X264 encoder and will send it through RTP. This stream will always be live. We could actually stream anything from VM to somewhere and then we can connect and decode it. Then this is just an example how you can generate test stream. You don't have to use it, you can find your scenario for your application. And this is a bit tips of what you probably would like to see, like GST debug. It's debug messages from MSDK and VAAPI. It's some of the you will see in the couple of more slides graphs how the GStreamers look like and maybe runtime dir directory. Now this is about how the GStreamer is draw the pipeline, and one of the example is if we play directly from the SDP, for example, directly using H264 decoder with VAAPI, getting down to the graph that is created with GStreamer, we can see that it does use VAAPI decode bin, and on the decode bin we can see that it does use directly VAAPI memory, which is somewhere, not here. Yes, VAAPI decode. This is VAAPI decode that was used in GPU unit of Apollo Lake. Okay, through the drivers, and those graphs is helping you to see all the pipelines of the decoding pipelines, for example. This example as well, you might need it, might not need it, but it's like if you want to check your performance, for example, you can decode once at the beginning, streams that is sent from VM, for example, and then use multiple encoders through the pipeline, which in this scenario is 1, 2, 3, 4, 5, 6, 7, 8 encoders of the same resolutions that it was sent, and it's probably 1080p sent from the decoder, 8 encoders, then it's one decoder 1080p and 8 encoders 1080p in the same card, which is quite good quality because we're not using software CPU processing power, we're using only GPU power of the card. And this is a graph. Because this is pipeline, we can notice that it's only one decoder get from the memory, and it's uncompressed NV12 format 1080p, and push to the encoder through the VAAPI encode modes. We can see bitrate, VBR, we can see what the resolution come. It's no cutting or post-processing right now. It's only encode and throw away the data, which is mostly as a benchmark good, but we can go and push this data forward. So this was about GStreamer, and the last bit of is tools how you actually can see the GPU is actually in place. On the VAAPI you can use Intel GPU tools. It's a package that you need to enable in Yocto project and build it with. To do it is you need to change local.conf file at Intel GPU tools there. You need to put the Intel GPU tools inside of recipes of the graphics for the Intel middleware and build your Yocto project. It's look not intuitive friendly, but if you know what you need to do, it's very easy to replace and like update the version, for example, from 23 to 24, for example. And when you actually watch the graph how it is in place, you can see that GPU current rate, what is used, it's probably for one of the scenarios, and the GPU in the CPU it's very low, like 21%, but GPU is 84%, and it's probably higher than you would expect because it was maybe 1 decoder and 8 encoders, and it does need some memory transfer somewhere. Then this is tools that you can use, and it's probably end of my presentation for today. Thank you for watching. I'm enjoying to make more presentations, and probably I'm planning for AV1, maybe VCC, new codecs, but thank you for watching. Join my channel. Thank you very much. Bye bye.